Right, so we have dealt a lot with ratios, rates, unit rates. Now we're looking at the topic of complex fractions, which goes right along with things that we've already done this year. Just kind of stepping up our game. Now, while you're watching this video, if you need to pause or you need to rewind, or you need to slow things down or speed things up, remember those are all things you can do with the video. And so take your time and do what you need to do in order to understand the topic fully. So with complex fractions, we're going to start with the definition. What we've been dealing with fraction-wise so far, you probably would term more like simple fractions. Complex fractions are a little different in that complex fractions are fractions with, a numerator and I'm going to go to the next line, denominator. You're remembering, you're filling this in with me. A numerator, denominator, or both. And the end of those that are also fractions. So with complex fractions, you have a numerator, denominator, or both that are also fractions. So for instance, if my fraction bar is here, and I did 1/2 divided by 20, I'm going to highlight there, I've got a fraction in my numerator. I could also do, let's say, 15 divided by 2/5. I've got a fraction as part of, here I'm highlighting, part of my denominator. Or I could have 3/4 divided by 2/3, and now both my numerator and my denominator have fractions in them. So complex fractions have just a fraction within a fraction. So when we have complex fractions, we want to simplify them. And in order to simplify them, and complex fractions here, the statement is complex fractions are simplified when both the numerator and denominator are integers. In other words, they are not fractions. So our numerator and denominator are no longer going to be fractions. So how are we going to actually do this? How are we going to do this simplification? It's actually, we're going to throw back to things that we've already done before, remembering this important piece that a fraction can also be written as, actually I want to change that to a division problem. Remember that a fraction bar itself, when I see 2/5, remember the fraction bar there really just means division. So how's that going to help me do my, to simplify my fractions? Let's look at the examples here. And so the structure you can see, we're going to do I do, we do, and then you're going to have you do. With the I do's, that means I'm going to show you exactly what to do in the problem. You're just going to kind of copy along. With the we do, I want you to do a little bit more independent and kind of think through. I'll still work through the process with you, but the you do's, you're going to be trying on your own. So for the first I do here, we have 3/8 as our numerator and 1/4 as our denominator. We have the fraction bar in the middle. So remembering this fraction bar here means division. So I'm going to rewrite this problem. This first thing I want to do is rewrite my problem as a division problem. So you should be writing down exactly what I'm writing down here. I'm going to change 3/8 over 1/4 into 3/8 divided by 1/4. So when I do a division problem, and actually I'm going to scroll back up and I'm going to write this above division problem. How do I take care of a division problem with fractions? Well, we just finished up fractions. So hopefully this is fresh in your mind. We're going to keep it, change it, and flip it. We have a fraction division problem. So I'm going to keep it. I'm going to change it to multiplication, and I'm going to flip 1/4 into 4/1. So I flipped that second fraction into its reciprocal. And this is how I'm going to deal with complex fractions. I'm just going to simplify by writing it as division, and then dividing the two fractions. So if I did multiply here, 3 times 4 is 12. 8 times 1 is 8. Now reminder, if I get 12 over 8 here, I need to make sure I simplify. So I can simplify either after the problem is done. So if I do that, 4 is my largest divisor. Or if I look back at the original problem, I could have noticed that 4 and 8 here had a common factor of 4 that I could have divided out. But if I didn't notice that until now, that's okay. My answer is 3 over 2, which is also, I'm just out of room here, which is also, if I write that as a mixed number, 2 goes into 3 one time, and we have 1 left over. So I'll take 3/2 or 1.5 is my answer. So write your problem as division, change it to multiplication, and follow through. Okay, so the we do again, I want you to kind of think through this, maybe pause at spots and see as you go along if you're correct. So we're going to write this and notice the division bar here. Our numerator is 2/3 and our denominator is 9. So I'm going to rewrite that as 2/3 divided by 9. Now before I divide this, because I'm dividing by a whole number here, because I'm dividing by 9, I got to change that into that fraction. So I'm going to make that 9 over 1. And then, how do I do this problem? Well, I'm going to keep it, I'm going to change it, and I'm going to flip it. If I look at the cross numbers, 2 and 9, 1 and 3, there isn't any simplifying I can do, so I'm just going to multiply. I have 2, and 3 times 9 is 27, so my final answer, 2 and 27 don't have any common factors, so 2 over 27 would be my answer. Okay, you've gotten a couple of examples here. You've gotten an I do and a you do, and a we do. Now it's time for you to try the two at the bottom. You're going to pause the video. I want you to try these two, and then watch and see if you got the right answer. So I'm just going to run through these quickly. Rewrite as a division problem, keep it, change it, flip it. Look for any canceling, look for cross canceling, and you might want to star that and write that in, cross cancel, if you don't remember that often. And there's no cross canceling, so I'm just going to go ahead and multiply 4 over 15, no common factors, 4 over 15 is my answer. For my second you do, there's my division bar. Rewrite the division. 14 is 14 over 1. Rewrite as multiplication, so keep it, change it, flip it. I see some cross canceling. So I've got 18 over 1, which is the same as 18. Okay, so you've got your answers on your you-dos. Again, complex fractions are just division of fraction problems. All right, on our second page, how are we going to use these complex fractions? Well, we're going to connect them back to what we've been doing in that, where are we seeing division? We're seeing division when we're trying to find unit rates. So unit rates can be found for values that create complex fractions. So I'm going to do one problem here, and then you guys are going to attempt to do one very similarly. So make sure you follow along and you're writing along with me. For the I do, it says Joseph can jog 1 1/3 miles in 1/4 of an hour. What is average speed in miles per hour? Per means there's where my division is happening, and this would be the top. Miles comes first. Per hour, this would be the bottom. So when I write my ratio here, if I'm going to do a unit rate, I'm going to put miles on top, and I'm going to put hours on bottom. So first thing I want you to do is write your complex fraction. So I have 1 1/3 miles and 1/4 of an hour. So that's definitely a complex fraction. If I have a complex fraction here, how am I going to figure out what the answer is, what it is in simplified form? Well, I'm going to take my problem and I'm going to rewrite it, just like we did on the previous page, as a division problem. And I'm going to simplify it by turning it into multiplication. So before I turn this into multiplication, I need to know that 1 1/3 is 3 times 1 and plus 1 is 4 over 3. So I have 4 over 3 divided by 1/4. I'm going to keep it. I'm going to change it, and I'm going to flip it. There isn't any cross canceling. I'm looking at the 3, I'm looking at the 4, I'm looking at the 4 and the 1. No cross canceling that can happen, so I'm just going to multiply. 16 over 3. Now when I say 16 over 3, that doesn't necessarily give somebody a good idea of how fast you're going. So let's change this. How many times does 3 go into 16? That would be 5. 3 times 5 is 15, and we have 1 left over. So this would be 5 and 1/3. And my units, make sure we include our units at our answer, would be miles per hour. All right, there's the I do. So write our rate with our units, change it into the division problem like on the previous page. The only difference is now we're throwing some units in. So you're going to pause the video, and you're going to try the you do before watching the answer. Okay, Mr. Smith is spreading mulch in his yard. He spreads 4 2/3 squared yards in 2 hours. How many square yards can he mulch per hour? So we should have a rate that is square yards on the top, and per hour means hour goes on the bottom. So that would be 4 2/3 square yards divided by 2, or over 2. So let's change that into my division problem. 4 2/3 divided by 2. Let's change this into an improper fraction so that we can multiply. 4 times 3 is 12, plus 2 is 14 over 3, divided by 2. Make 2 over 1. And then to get my answer, I'm going to keep it, I'm going to change it, and I'm going to flip it. I can multiply now, or I can notice, I can cross cancel here. Both of those divide by 2. So I have 7 over 3, which is 3 goes into 7 2 times with 1 left over. 2 1/3, and it would be square yards per hour that Mr. Smith can spread. That's how much mulch he can spread per hour. That's his unit rate. Now when you're doing your practice, make sure you're paying attention to the units, writing out your complex fraction first, and then simplifying it by doing your division.